Hello, welcome to Bay Piggies. I'm Dennis Reinhardt. I'll be the first speaker tonight. It looks like our other speaker isn't here, and the third one is ill, so this may run a little bit longer than was originally on the schedule. I'm going to try and shoot for like 35, 40 minutes as opposed to 25. There's plenty of code material here, so let's get started. What I'm going to be talking about is 3 generations of user interface for the same program. I've implemented the same program using different user interfaces. And this program was originally designed as a user interface experiment. And it's my test bed for working with the user interfaces. But this isn't about that particular program. That'll emerge. There are basically 3 different methods I use. The first that I started with was a direct use of Windows API. In other words, I use ctypes, which allows you to communicate directly with DLLs. And I implemented a user interface that goes back. The method goes back to Windows 3.1 and before, often known as a Petzold interface. In other words, you're talking directly to the Windows DLLs. Not a lot of people do that. wxPython, Ken Seahart was going to talk about that at more length. That was one of them. I'll be addressing that. And then a couple of ways of implementing HTML-based processes and conclusions. For those of you who are looking at this on Google Video, there are a number of program listings that are going to be unreadable. So follow along with the URL that's listed here, and the URL will be given several times throughout. So pull it up on your computer to follow through with the program listings. So first let's start with the direct Windows API. Program interface, the main program view is shown at right. You see, this thing is basically a drag and drop icon. When you can drag that outside the boundary of the window and drop it on another program. That's one of the, so this out of process communication is one of the things that makes this a user interface challenge. Most user interfaces, everything is confined within the one process, but this has both in-process and out-of-process elements, which makes it a good test bed. There's C-like coding, which you'll see some of, and most C programmers have the entire Windows API laid out for them. Well, you don't have that in Python, or at least I didn't. And one of the gotchas here is that you need to use what are called external resources. In other words, they're dialog boxes, things that pop up with little messages on them. And those are structured things that you build with Microsoft proprietary Visual Studio. And you can have them as separate files, and then you somehow need to hook to those. So let's look at an external resource. Here's a typical dialog box with some stuff you fill out and stuff that's constant and some buttons. Nothing real exciting about that. This is the definition of that dialog box. So, for example, here, this yes, oh, it's somewhere in here. Well, anyway, all of these items on screen are laid out in this text file. This text file is then compiled into a binary file, and many of these things are given numbers: 101, 101, well, a bunch of 101s, 1015, 1012, 1013, etc. Those numbers then get entered by hand into a Python program, so that I've defined variable names or names that are equal to those numbers. So there's no other coupling other than those numbers. So given that we have those numbers in our Python program, the code that reads and writes the dialog box is pretty ugly looking. It's not particularly beautiful code, and in going through it, you don't have any good. I don't have any good mental model of what we're looking at in terms in physical terms, but it works, and it's tough. It's tough to work with. Yes, Ross.
So is the Python then through this object or this page handling code generating that blue DialogDevil edit page or screen?
Question was, is the Python code generating the screen that we're looking at? And the answer is in part, yes. In other words, the Python code is supporting it, but there's an object, an actual file object, which is called a resource, which you then pass to an API, and the API shows the empty resource on screen, and the code, the Python code that you're looking in, fills in the variables. Okay. Anyway, that is the direct C API. I got one thumbs down. The next one is I tried re-implementing pretty much this interface in wxPython. And what I wanted was a higher level interface. In other words, I think I've convinced you that what you saw was pretty low level. It worked. I was able to put stuff up, but it was tough. It was tough to work with. Here is the front page of new interface. There are various tabs here. You'll notice that the tabs aren't particularly well delineated. For a while, I've struggled with that because the tabs are supposed to have a little orange top to show that which one is active. And I'm surprised that I finally figured it out. In other words, that the path that's used in the Python 2.5 Python distribution has to be followed precisely. You can't just move things around and change the sys path, which is what I did. It worked and it ran, but there were some dependencies there. And so when I went back and made the Python path exactly follow the tree structure of Python distribution, I think I'd fix that. But so as I was looking for a higher level interface, basically what I used are tabs, which you can see here, splitters, and a tree, which you'll see in another picture. But most of the pages were actually HTML. It was just, it was easier to work with when I wanted to just put some text up on the screen. wxPython has a concept called, sizers. And boy, try as I could, I never really internalized how to use sizers. I was always having to look at an example and kind of copy and paste it, and I never quite figured out how that actually worked. But I got it working. I didn't use a lot of native features, but I used virtually all of the. But these few features used virtually all of the DLLs, or the PYD files, as they're called. And I'm clearer, that just those few, I had to pull just about everything in. There was a control they called the grid sizer, which that was about the only one I didn't use. And there was a heavy memory footprint, which I'll go into later. So here's here's same interfaces you saw before. You remember on the native window interface, there was a bunch of things that, a bunch of pictures that were listed. This is now split out to a separate tab and made two levels. And what we're showing here is the wxPython code. We can actually see it. For building this particular tree structure. In other words, there's an in-memory structure that contains objects which we step through. We pull the file name out of the object, and then if the file name changes, in other words, we're going down here. So every time we see a new file name, we then go down this path, and at this point, I think it's at this point. At this point, we add this element at this point, and then for all elements that we're stepping through, at this point, we add this second level, and that's the code which generates the tree. But because there's no way to manipulate the tree, or there wasn't intended to be. So I had implemented something where we just rebuild it from scratch. In other words, there's no good insert delete kind of mechanism. And so there's something which essentially just zeroes, just throws the entire tree away and then rebuilds it from scratch. And that's how add delete is implemented. Here, this is what I think this is this other page, and here you can see that it's much easier to correlate what's on the screen with what's in the code, largely because parts of it are HTML. These icons here, there's a subroutine call. There's a native. These are native objects rather than HTML objects, and the reason is because we're going to have to drop the mouse on it and drag it. And if it were just an image tag, we couldn't do that. Well, caveat: we could do it with JavaScript, but JavaScript implementation has the limitation that you can't go outside the boundary of your own window. So that's kind of useless for controlling something else. But so if anyone says, yeah, but you can drag it with JavaScript, yeah, to a point. All right. So that was the whirlwind tour of WX. So we've seen basically a Petzold level C implementation, and WX. Third one. Now this splits into two parts. All right. In other words, I wanted to redo this entire thing in HTML, and this is going to get a little technical here. But the first way. The obvious way that you think of is, here's my app. I have some sort of in-process DLL which interfaces to what's called a COM object, which has Internet Explorer, it turns out, resident. And so I can talk through this DLL, which talks COM to Internet Explorer. My application now can use Windows API to talk to the in-process DLL, again with ctypes, and it can. It also sets up an HTTP server internally so that it can talk to the HTML, right? And that's clean, it's nice, and it's about 97% functional. But that last 3% is a killer. And what is the 3% which doesn't work? What doesn't work is copy-paste. In other words, if you take a block of text and drop it into an HTML form, nothing. And I've forgotten whether it's the delete or the backspace key doesn't work. One of them doesn't work. And so if you ask somebody to enter some text in, what they're going to see is that the delete key doesn't work and they can't copy and paste. Immediate conclusion is, no good, doesn't work. Erase this. And so that was not real helpful. I did some research, and this particular DLL was written in 2002. Others had seen the same thing, hadn't been able to fix it. I actually went through the C code and fixed one of them, and I think it was a copy paste, but there were allegations that it wouldn't work with Internet Explorer 7, but that didn't make any sense because the COM interface is immutable, and so the interface ought to work. But in any event, I got rid of it because it wasn't Python, and it wasn't working. So I went down below. Microsoft releases a shell for Internet Explorer. All right, it's basically called a HTML application, and it's got about 30% of the functionality you'd want. And what it does is it puts up a frame, a window, and you can run HTML in that window and control the icon and the title and stuff like that. I was going to go in this direction anyway, so it just seemed like because I couldn't get this obvious approach working, I'd go this way. And it also had, so there's two separate processors here, processes. There's, what's my application, communicating with a separate process, which has its own in-process DLL, the Internet Explorer. I talk again to the HTML through HTTP and use a Crossprocess API. Well, that's not exactly the same as having this, that isn't the same API as if you're talking to things that you're in your own address space, but it's possibly workable. And yeah, there's some complications with that. It was more painful than I would guess.
When you put in the, like for example, if the HTML you're generating has a reference to an image, how does it know where to find the image?
Okay, how would the HTML know where to find an image? Basically, I wrote the web server, and so I took care of that. In particular, I took care of that by looking at the extension of what you're loading, so that the py, it calls a Python program, and if it sees JPEG, etc., it pulls up and delivers a binary image from a file structure, that it maintains. So, here's this is generated entirely in HTML. Here's the same tree structure that we saw before, done in HTML. Here's the detail for this particular selection. You notice that this is twice the size of that. It was meant to be, to emphasize where you're selecting. And for my money, the tabs are superior. These are basically CSS tabs, right? In other words, I did it with CSS. I looked up, how to do it in JavaScript, but CSS was superior, and there's no need for JavaScript here. So let's look at some Python code again. So what we're doing here is this is the same, pretty much the same Python code as we saw in the WX example, where we're going through the same in-memory structure, checking to see whether we are encountering a new top-level name, and if so, throwing out HTML which I would expect most of you can pretty much read, all right, to generate this icon. And there's some deleted code here, but it's more the same to generate this second level. So it's pretty much the same structure as you saw for WX. The amount of code isn't impossibly larger, and fairly readable. Here's a breakout of what would have been a dialog box, but is and you can basically see there's pretty much a fairly easy linear structure in HTML between what you see and what's coded. Not the world's best Python, because it's just intermixed HTML, but easy enough to work with. All right, I promised complications. Well, here they are. I don't have code because it's painful enough that I'd rather talk about it and not talk about the code. Remember that what we're trying to do here is that we're trying to drag an icon off the window for our process and onto some other process. Well, that first, the first thought I had here is, okay, what I'll do is I'll throw up a left bracket image, and then for a I think on a mouse down, all right, or I think it's mouse over, one of those JavaScript things. I'll throw out a HTTP request, all right, which then I throw back a 204 response to, in other words, meaning no change. And so I've notified my own HTTP server that I've seen this mouse activated, and then I go grab the mouse and do stuff in a separate thread. Well, no go. There were several no-goes. Let's just run through them real quick. One of them is that when you go off process, you're not tracking that fast, and so you can move the mouse back and forth too fast and lose mouse interrupts. Now, I think this is related to having to communicate through HTTP in a separate process, because if you go to something like Google Images, where they've got a bunch of images with mouse overs, and you just whip the mouse back and forth, it tracks it and it isn't losing anything. Whereas here, if you move the mouse back and forth, because it's got to throw off an HTTP process, and it loses state, and you end up staring at it. The second thing that's a problem here is that because the mouse now belongs to this Internet Explorer process, my separate process can't access it. In other words, for example, there's no Windows function, where is the mouse now? You get notification only if the mouse is over your process, or you've captured it, but you can't find out in general where the mouse is. JJ.
You said you were notifying your web server about the mouse movement, and you said something about a 204 response. Were you trying to reload a new page, or were you, which I would expect the browser to kind of lose its JavaScript state and stuff, instead of using like a XML HTTP request, which seems a little bit more natural, whereas it might have.
Okay. Explain a little bit more, and go into a HTTP and go into an XML request. All right. What the 204 was doing was it was telling Internet Explorer not to repaint. In other words, what I was doing when I did on mouse over, send out a HTTP request, it was basically a one-way message. I was sending a message to my server, and the server, because it's a request response protocol, sends back, fine, got it, don't do anything. Just show what you've got already. Right? So that's what the 204 was saying. Keep showing what you're doing and don't change anything, and I got your message. Now, the term is eluding me, but there's basically asynchronous JavaScript. There's a synchronous JavaScript request which you can throw off, and it would seem natural to use that, right? Yeah, XML HTTP request. Well, I didn't. Yeah, it sure would seem natural, and unfortunately, and I tried it. All right, and what I found was that evidently in the Internet Explorer implementation here, there's a single thread. All right, and so I was able to hang up Internet Explorer if there was an outstanding XML HTTP request, and so that was terribly non-robust. But basically, it didn't work. Wasn't it worked, but it was way too easy to get into a deadlock situation.
You could do them asynchronously.
Oh, I know. Oh, I know. And in fact, my app was multi-threaded, and I guess what I'm saying is that over in the Internet Explorer side, it wasn't adequately threaded. All right. In other words, you certainly couldn't have multiple XML HTTP requests out. Now that may be different with Internet Explorer itself, but the embedding here, all right. In other words, I'm limited by, in this implementation, I'm limited by how the rendering engine is embedded, and I think it was embedded in a single tasking framework. All right. So anyway, I didn't do that. Now there's a third problem. I've forgotten what it is. Oh yeah, there are a lot of APIs which simply didn't work. What you're in fact looking at here is two separate windows. This framed element here is a window which is generated by the resident part and is simply overlaid or put on top of the HTML, so that when you drag one of these things, it's in process and bypasses the HTML. And it was real painful doing that because several of the documented APIs didn't work the way they're documented when you do this kind of cross-process. But it eventually worked, and most of those were related to the mouse. All right. So conclusion. All right. I did this. Part of what was driving a lot of this was memory considerations. Going direct to Windows, the download size and the amount of memory, all right, which I'm showing both, all right, were fairly small. And the first kind of level takeaway here is that download size and memory resident part by happenstance happen to work out to be about the same thing here. And so I was very concerned in the WX implementation, which this is, about the memory footprint. It exceeds 10% of a quarter gig system, all right, which is a lot for what's a it isn't an essential component of your system. It's clicking dialog boxes, that's a lot of memory to take up. The hta implementation. Oh, plus the second time in many years that I ever crashed Python was with wx. All right. First time I reported here was the ctypes tangling with malloc. Yeah. And this wx crash was that I tried to unload wx, when I close the user interface. Now, my program runs continuously, but the memory interface runs infrequently. So I wanted to simply close it and unload all that stuff when the memory interface is closed. And that worked until the second time I opened the interface, and then it just crashed. And it took a while to trace that down. But basically, wx really, once you start it, it's got to be there, or you crash. So I think it's fair to show that the amount of memory is the full-bore memory, because you can't unload it. Here with the separate HTA process, you can unload the decoupled display part, and so I show here two separate memory sizes. This is the normal case when the interface isn't up, and here's the much rarer case when combined. So questions or comments? That's it. Thank you.
Any comments on the actual user experience?
Any comments on the actual user experience? Well, I think there's been some evolution in sophistication along the way. All right. On the other hand, the overall computing environment has seen evolution in sophistication too, and whether this is tracking slower or faster, I don't know. No, I don't think it's all that. I don't think it's all that different. In other words, the first interface is a couple of years old, and to import something that's a couple of years old and do it now is less satisfying than something that is more recent. But I don't think that's a major factor.
Do you have any thoughts about cross-platform? There's the Mac GUI, there's the Linux desktop, there's possibly a Solaris user still working on that.
Yeah, I do. It's fairly clear. It's fairly clear that this decoupled model could indeed serve as a foundation for a cross-platform GUI. In other words, that you have a resident HTTP server, and that you're simply serving up web pages locally. As long as this miserable cross-process API is minimized, this is one of the things that attracted me to it.
I'm actually I've always wanted to do an application that was exactly like that, but with Zool inside Firefox. So you get the native look and feel, but you still get to have all your code in your Python web server and still get decent widgeting, so forth.
Comment, but I guess doing a Jeopardy style and making it a question. Why not use Zool with Firefox? The answer here is that you can depend upon Internet Explorer. being on the client system. If you could guarantee that Firefox is there or that you're distributing it. For example, if you're doing a CD distribution, yeah, you don't care what the download size is, and you just distribute it. But if you're doing internet downloads, it'd be simpler to simply depend on what's there. And in fact, this component could in fact be a web browser. In other words, you simply launch the web browser with a URL points locally. It's a little uglier because it's got all the web browser Chrome on it, and this cross-platform API is made considerably more difficult.
Firefox actually has a command line flag to turn off that Chrome, so you can fix that problem right away with Firefox. It's neat, and I'm surprised more people aren't doing it.
Another plug for Firefox. All right. You ready?
Sure.
All right.
Oh, sorry. So just to intro, this is new code just for this meeting. And is David Reed here? I don't see. Didn't make it? All right. He helped me. Oh, my God. All right. Well, he wrote some of this code and worked with me at Super Happy Dev House, which was last weekend, a hacker party that's around here, which I recommend. And you just show up and work on anything, including Python profiler visualizations. Oh, I need to push buttons here. Better. Good. Yay, it's profiler. Everybody's run the profiler and seen this, right? Okay, I'll talk about this. And then I just want to ask, has anybody used KCacheGrind to look at Python profiling results? All right. It'll be a surprise. I didn't know about it before. So here we go. Profiling means, what's that? Oh, sorry. So profiling means running your program in a way that you can measure how much time is spent in each function, and then you get results like this, which show you that the majority of the time was spent in a function called create that doesn't have a module with it. Why is that? I don't know. There will be lots of profiling details that I don't know, but I do know how to make this look better, and that's what the talk is going to be about. So the results of this profiler say that the CPU is working for 0.9 seconds, even if the program was running for 5 minutes. And it spent the majority of its time in a function called create, and then the third most time was spent in SRE parse. So you would know that if you wanted this program to go faster, looking at the thing that is calling the regular expression parser would be a good place to look, see if you could cut down on regular expression parsing or something. I don't even remember what program this is. I might have been profiling the profiler itself or something, just to get an example. So the terms here, Hotshot is one of the Python profilers. There are a few different modules that you can use to get your profiling results. Hotshot is one of them that's been in Python for a few versions. cProfile is a new one that just arrived in Python 2.5. LSProf, has anybody used that? All right. LSProf is a outside the standard library one that I hear is good. Is it good?
I thought that was just the previous name for cProfile.
Oh, LSProf became cProfile. All right. Well, I didn't get into trying those, but I've used Hotshot a lot. And so we were getting results like this all the time. I'm working on a website, so soon you're going to see functions that are all representative of web server. Yeah?
When the number of calls has a slash, is that
Oh, sure. Yeah, that's right. So when the number of calls has a slash, it means that the function called itself possibly through a chain of other functions. So what is this? Flatten called possibly another function, which then called flatten again. So the second call was inside the call stack of the first one. And one of these numbers is the total number, and the other one is the internal calls, I think, or some arrangement like that. So you can see it only comes up sometimes. Yeah.
So when things like SRE parse is called, does that then wait
Well, this function is from the SRE compile, and the function was called compile. So I'm guessing this is the function that does the work of analyzing your regular expression text and putting it in a form that's ready to run. So this happens. I don't know if I'm answering your question.
I think it's cumulative versus per call.
Oh, sorry. Are you talking about the timings, or just what does the time mean for an example function like that?
How does it determine the time?
Yeah, does everything that it calls after it, that it calls subsequently?
Yes.
Or
So.
wait for it to come back from the stack?
So correct. So roughly speaking, the profiler notes the time when the function enters, and then the function calls many other things, and then the profiler notes the time when the function leaves. And that, like JJ said, is the difference between total time and cumulative time. And now I'm even blanking on which one is which. Total time is only within that function, and cumulative time includes the children. So you get both results. Is that what you're asking?
Exactly.
Okay, cumulative includes the children. Total is minus the children, so it's just the time in that one function. So what that means here, like if we were analyzing these results, SRE parse is out of my control. I'm probably not going to edit it, and I could at most file a bug to Python to ask them to make it faster. So when I see this taking up a lot of my total execution time, the best thing I can do is just call it less often. But in contrast, if the function was one of mine, I don't know, suppose this net connect init was one of mine, I might actually be in control of this and be able to cut down on the number of loops or something, or do fewer string operations in there and actually make the function faster. So you either call it less or make it faster. Those are some approaches once you have these results. But let's go into the pretty stuff. So I've been looking at these results for years. I didn't even know about other systems like KCacheGrind, which I'll show in a minute. And the project I'm working on is a web project. And so we've gotten in the habit of just making web graphs for everything. So this is not profiling. This is just the kind of stuff we do. Is we benchmarked at one time, and then we benchmark the tests a different time, and we could compare them. So along those lines, I wrote a program. Oh, great. Called Psets to web, which takes the profile's results. The profiler's results are usually a big binary file that is just every function call, enter, and exit, and who called it and what, and made not that, and not that, but this. So this is the same table. So this was all I was going to show last meeting. This is the same as this table. The functions are in order by total time, but it's been dressed into an HTML table, and then I put in cool div bars behind here so I could actually see the sizes of the numbers against each other. That's all I wanted. And then as I started to get carried away, I also colored the files by what area they were in. Are they standard library, or are they one of my modules? So by squinting, you could get a sense of, well, smaller. Oh, it was rendering a huge table. But possibly you could squint at this and see, oh, the purples are really making it to the top, and purple is my database engine, so I'm really wasting a lot of time in database engine. That was the idea. That's something you can't really do with the text form so well unless you're using grep or something. You still wouldn't get this sense. So I think there is something new in the visualization, is that we can see the sizes of the numbers and the grouping of the files. Other features of this are that it's a flat, a single HTML file which can be archived and passed around easily, about as easily as you can pass around the text profile results. So it's easy to keep records of these and compare old ones and new ones, whatever. The file names are links to the source, so I should be able to click on one and go to its source, whatever. So this is what I had. Questions about this? So now I'll show a few more ways to look at profiling data. So this one completely existed, and I'd never heard of it, and I didn't know anyone was doing it. And I stumbled across it recently while researching this stuff, and it's actually great. So KCacheGrind is a fancy viewer, part of the KDE development tools, that I think was originally designed to view like cache, like your CPU's cache, that you could analyze your compiled code and see where it's making cache misses and stuff, and do really careful analysis like that. But KCacheGrind can draw all sorts of related things, including just boring profile results. And there is already a thing called Hotshot 2 call tree, which you can get in this Ubuntu package or wherever KCacheGrind tools are sold. And you can run your Hotshot binary stats file, which I just threw in my temp directory, and make a KCacheGrind call tree file. And this is cool. So this is KCacheGrind's format, which is kind of texty. And the Python profile results are sort of massaged, so they kind of fit like C profile results. There are a few mismatches in there, but it's mostly fine. We can do KCacheGrind call tree. Wait for KDE. And then all kinds of fancy things. So I've only looked at this for a few days. I can't see my own screen. Only looked at this for a few days, but what I found so far is that you can do the cumulative time, or you can sort by the self time. You can look at all the functions, and I had a good one written down. ParseTerm. Narrow down to ParseTerm. This is a map of when ParseTerm gets called on average. Here's where it spends its time in child functions. So ParseTerm spends the majority of its time. A little bit of time is spent right in ParseTerm, and then the majority is spent in new, who has another child cast Python to literal. So if that could be made faster, my ParseTerm would go faster, and so on. And then even, whoa, no. There are a lot of charts in here. This is a neat one, which is ParseTerm. And I don't really know this code, but clearly this is ParseTerm and the various functions that it calls, and the proportions of the time that are spent in the functions that ParseTerm called, and you can even walk up and see who called ParseTerm and who called what. Like this could be interesting just to understand someone else's code, aside from all timing reasons. I think it could be worthwhile to just run their code through the profiler just to see this graph, which can do some more tricks. A lot of tricks, which I don't know. Hey.
Approximately how much code are we looking at here? Are we looking like a 50 lines of code, or what?
The thing I profiled here was my RDF server, who itself is in the few hundred lines of code, but it uses twisted. So there's, what, 10K lines. It uses element tree, which is not that many. A number of large systems are underneath it. So I don't know if it's easy to see that here. Well, that's the total number of functions, so you can guess from there. One feature, so now that I found this, now I'm looking for ways to make my solution better than this one, so at least mine has a purpose in the world. One problem here is that the majority of the program's time, because it uses twisted, is spent in select reactor. So much time that the auto-scaling for these bars is kind of shot. We get a high-resolution bar for the call I didn't care about, and then we can see one more call, and then we can't see anything on these relative bars. And you might have noticed when I showed my version that I just chop off the first few. So I actually have a chance of seeing the reasonable functions, and not, like, this is part of the event loop. So twisted event loop is always running, and I don't care. That's what the program does in its idle time. The ones I care about are the ones right below. So I took a little care for that. I'm not sure if I have anything else for KCacheGrind. You can browse a lot of stuff. I've been playing with profiling data for a week, and I still can't understand how they do their percents in here. And there's that mode, and it'll take some more reading and some more experimenting. But I imagine someone who's comfortable with those would be able to read pictures like this pretty fast, and then the callee map, I think, is straightforward. Like if you had the function you cared about, you could easily see where it's spending its time in children. Questions about that? All right. What else do I have? Oh, so in my spare time, I play with Semantic Web stuff. And let me show you something I found in my spare time. A web page about the presidents. But it gets exciting because you can limit to the Democratic presidents, and then you can see more details about them sorted by party. Oh, except I already limited the party. Grouped as sorted, so it cuts the thing into chapters, and then each of these presidents has coordinates for their birthplace, so I can just throw birthplaces on a map, or just the Democratic birthplaces, or, oh, it broke. So this is something coming out of MIT, which says if you have a reasonably small amount of data, you could put that into JSON, which is a data format that JavaScript can read easily, and just send the entire data set to the browser, and then we could make various JavaScript libraries that show the data and group it and sort it. And then I think they did a nice job with this user interface. Like there's grouping and sorting possibilities that even the desktop tools don't have. So I recommend it. It's called Exhibit from simile.mit.edu, so we can go to their death places. And then it's got a timeline view. So there are these various, well, that doesn't show very well, various views. And it's not what I thought. The other thing is they have a bunch of nice examples like breakfast cereal characters. So now I'm just web surfing, which you can narrow down by brand and then show them on the timeline of when they came out. So it's all the same. So I knew about this, and then I thought I would like to try this with my profile data. So I think you can see the connection now. Yeah, it's a mashup. That's what they're called. When you profile breakfast cereal, that was the comment. Yeah, mashup, right. That's the only thing it means. So my Psets to web, again, is the Python program that I wrote with help from David Reed that reads Pstats, for which we have modules, and then it outputs either an HTML table, and then we added a little bit of code. I'll show you how little. This output thing, the format JSON, comes up with a record for each function that's listed in the profile, and preps the data for a JSON serialize, which turns Python data structures into JSON data structures. JSON is pretty nice and can be, like you can easily go back and forth between Python and JavaScript. It's worth a look. I won't go into it here. But so using Nuvo, which is another project from the Twisted people, they provided me with JSON serialize. So this is the whole function once you have your functions out of the profiling data to emit a really scary file that looks like this. So the JSON serializer doesn't bother with white space because that doesn't help. And there it is, all my items. Then, now we're talking about how to make an exhibit. Exhibit, you get your data looking like this or similar, and then you write a custom page on how to display this stuff. You use their JavaScript from MIT. Skip that. You can do CSS styling. And this is the whole thing. Except I can't scroll comfortably. There. So the exhibit JavaScript walks through this little skeleton page and recognizes, oh, a view? All right, I'm going to make all the view mechanics right there. Oh, a browse panel? Great, I'm going to make browsers for group, file name, and function. So this is what it's like to set up an exhibit. It's extremely easy. And if you don't do anything, you get a reasonable default. So I'm a big fan of the exhibit system. So now we will see my exhibit. So that code at the top that I just blew past was, once again, my little div maker that makes those div bars. So exhibit didn't know how to do that, but I taught it. So now I have, again, my div bars. This is an exhibit table. I can say narrow it down to just the calls from element tree, plus the ones from Nuvo, except I have a couple builds of Nuvo here, which is why this is awkward. I could say sort by cumulative time now. So exhibit is providing all these sorting tables and grouping. Oh, and it's screwing up the sort order. It's doing an alphabetic sort order on these numbers, which is a bug that David Reed, again, was looking into for me, but neither of us has solved it yet. And then, yeah?
Zero fill the floating point.
Yeah, a workaround would be to do that. And then also my total times just happened to be the special case that will sort in order. So that it became a low priority for me when all my numbers were coming in order anyway. But yeah, that needs to be done right. Each of these records has the file name, encalls, everything you see here, and then it also has a group, and we put each file into multiple groups. We just peeled off directory names. So any subdirectory or sub-subdirectory is showing up here as a group. I know, a good one. So I thought there would be one for just Twisted. Oh, so here's Twisted Web, the functions that were from the Twisted Web modules, and then showing up again as web. So the idea, I don't know, we tried to make it so you would always find what you wanted in this group, so you could see the group of functions you wanted. Then I made the file name itself be a selector, so we can narrow down to just the ones in element tree using that. Ooh, JavaScript. That's not the best display. And then function, but of course, each row was a function name, so this is mainly if you wanted to just stare at doSelect and doWrite next to each other, I guess you could do that. It's great. So this is like one day of work this weekend, and I don't know what to turn it into. Like I've certainly gotten what I wanted, which was to just see who's at the top and what are the size of their bars. This was fun though, and I encourage people to play with it. And then I'll wrap up with not that. So here are the things that I'm looking for. So remember I said a profiler essentially marks the time at the beginning of the function and time at the end of the function, and then remembers that and who called and whatever. That's a lot of bookkeeping, and even the C, I haven't tried cProfile yet, and I know it's faster, but while I'm testing, I don't really want that program slow down. I just want to know which functions are taking the most time. And a statistical profiler does not look at the start and end of every function. It just occasionally, like how the census might do sampling on our citizens, a statistical profiler just every now and then comes into the program and says, what are you doing right now? And the answer that comes up the most often, well, that's the function you were spending the most time in. And a statistical profiler's overhead can be incredibly tiny. And I don't know of one. So I'm looking for a statistical profiler that I would just constantly have running. And every time my program exits, I would get at least the top 5 list. And I would just keep in my mind, if a new function is climbing to the top, then I could address that while I still remember how I wrote my code. So I would like to have that. I don't. The deal with Hotshot. So Hotshot is the profiler I'm using. The profilers are the one called Profile in the standard library, the one called Hotshot in the standard library, and the one called cProfile in the new standard library. Hotshot is really slow as your program is running. Like it just drags your program way down to do its job. Hotshot quickly writes down the data, but then when you try to read the data back, then you get a slowdown. So it just defers all that time to later, and it's still not good for your development iterations. cProfile or LSProf might be faster. I haven't looked into those, but that would be valuable to me. I'll skip to this one. Better filter groups in Exhibit. So here I was making the ones that were easy for me, like the group and the file name, but I don't even know what I'd want there. Like, you don't always want to group by module. I might like to group for just the functions that do disk I/O and see how they're comparing against each other, and that's a big project to figure that out. Or of the functions that are in the top 5, let's see them and anything else that's in files with them. Like, I think that could be useful. I don't know what else, so I welcome suggestions on that. What else did I write here? Yeah, files involved in top 10. Oh, callees. So remember that caller map when I went to ParseTerm and we could see what was taking up the time inside? That would obviously be good to have on Exhibit. I should be able to pick a function and get not just that function, but that function and everything that appeared deeper in the call stack. And then finally, and this is a Twisted only thing. Do people know Twisted framework? The asynchronous networking framework? So the deal in Twisted is that the call stack is kind of split up by the event loop. And briefly, the way this works is I make a call, and very loosely, the way this works is I make a call, and then I hand the result. I hand it over to Twisted, and Twisted waits for the result, and then calls my callback and a chain of callbacks. So most functions are being called from the Twisted event loop, and the profiler has no idea that, oh, those 5 functions were actually in a chain of deferreds. So, and this is only going to make sense to people who use Twisted, but I would like something that can keep track of the deferred chains and charge all that function time back to the original function that made the first deferred. And I haven't seen that done, so that would be a great project, I think. And that's all I got. Questions? All right. Thanks.
Actually, I have a question.
Yeah.
That serialized output that you showed, that's the native format of the JSON? Or
Yeah, so that huge mess of stuff is JSON. It's JavaScript. It's really JavaScript dictionaries and lists, which are close to Python ones, but not quite the same. Yeah, JSON is not a big invention. The invention was we could use JavaScript's data structure stuff as the way of passing data, and there are some good properties to that. There's some good write-ups on the web about why that's a good idea and why it's it's got big advantages over XML. So like the thing I'd like to leave you with is if everything is in your control, and especially if one is JavaScript, JSON might be the great way to pass stuff around. Anything else? All right.
We have some announcements. The topics that's brought up is a newbies night. Another one is PyCon. And PyCon is the immediate possibility. Are there people who are going to PyCon who would be willing to report on their adventure? Terrific. What talks are you guys going to go to? We don't know. Okay, that'll do. Anybody else?
JJ already sent his list out, so
Okay.
he's publicly admitted which ones he's going to.
Okay.
It's
Thanks.
a long list.
Well, hopefully we can use the Piggies mailing list to fine-tune this. Does anybody have any ideas about a newbies night? The biggest question in my mind is when in the next few months is the right time? In other words, when is nothing else happening? Any thoughts?
Right after the PyCon one, right? You can schedule them in any order you
That's
want.
probably what will happen. Okay. Got any thoughts? Announcements?
Well, not a kind thought,
Oh,
but to me, newbies night is another term for don't have a program.
oh, I don't think that's kind at all.
No, I said,
A newbies night, it seems to me, from the person, Stephen McInerney, who's interested in having it and promoting it, is an opportunity to invite people who are interested in Python, interested in the basics, and the fundamentals, the entry point, maybe some of the big design things. Why use Python instead of Perl 6 if it's ever going to really surface? Things like that. That's how I'm reading Stephen's request. Make sense? Thoughts?
One of the things that I think,
Yeah.
one of the things I think might work for a newbies night at some kind of meeting would be to go around and just talk about all the different domains we use Python in, to give newbies an idea of what's it good for? Why would I want to learn this? You know, you all have done other programming languages, most of you, maybe not me, but most people, and going around and saying, you know, I went to Python and use it for this because this is why I like it, and going around so people can kind of get an idea.
Can we do it in Alcoholics Anonymous format where you get up and you say, hi, my name's JJ, I've been a Python programmer for so many years, and then you give a 2-minute speech about how you got started.
Hi, JJ!
we love you.
We love you.
It's a good idea. Yes.
Well, I would say let's try this, put this to the same test that we put PyCon. In other words, how many people are going to volunteer to bring a newbie? In other words, are we going to be only talking to ourselves, and how many newbies are we actually talking about?
Oh, I was going to suggest one, sort of a topic that might be presented for newbies other than people that don't, not just selling Python, but something like Python idioms. I know where I'm working now, people are starting to use Python, and they have no idea how to make a program run. You know, the idea of having if name underscore equals main and that kind of thing.
Oh, I was just going to see if there's a show of hands in the room who would say they're new to Python. I mean, just come from a random sampling that we have here tonight, like who would say they're new? Yeah, so even if we don't bring in necessarily people, we're not, if no one raised their hands, then we would say, well, you know, we want to make sure we get some people who talk. But it sounds like there's people here who would be interested, so that's good.
Yeah, I have another suggestion, which is poll people who are newbies on the wiki about what they'd like to, you know, what they're into Python for right now, what they'd like to hear from the rest of us.
Why on the wiki instead of the mailing list?
either one is fine, but I thought the wiki is easier because they could just each post multiple questions and you don't get hit with the email every time someone does.
I have to say something here. Okay, since I've run a couple of newbie nights before, since I've been a member for quite a number of years, the way it's worked in the past is 2 people get up, one person does the talking, another person does a demo. So a live demo of here's a for loop, here's an if statement, here's a while loop, here's how to create a class, here's how to create a function, and then after that, that spawns discussion, and then everybody breaks off, and we have the engagement there. But it's really up to those of us who have been using Python to actually drag somebody in here who's curious about Python. So it's really up to us to bring as many newbies as possible to come for one of those nights. So we can do that on the main list, and they've worked pretty well in the past. It's a very nice, technically somewhat formal, not too deep, but enough to give somebody a high-level overview to see how simple the code looks. It's really all about looking at code and seeing how it runs. How fast can you write working code using the language? So that's what we've done in the past. It's been actually a couple of years since we've had a real newbies night, so I would suggest it, especially now that I think Python is picking up steam, more steam than before. So those are just my opinions on it.
Anybody have an idea about promoting this idea? How do we, let other communities know that we've got this in the works?
Buying a Super Bowl ad is out for the year.
I've made a pre-announcement to like SVLUG before.
It worked?
Yeah, it brought in a couple of people, like 4 or 5, but not the whole crew. Obviously, it's just whoever has any kind of interest in Python. So, but there's other user groups. There's a FreeBSD user group, tons of Linux user groups, even people that have Mac OS, Mac user groups, because guess what? Python comes with Mac OS now. So, lots of different places, but we have to just actively go and do it. We have to set a specific date, and then people have to actively go and make it happen.
There was someone I talked to last meeting who has a Python program that controls a laser cutter to cut paper. If that person identifies himself, so I have a pairing for you. I have a woman who writes Python and uses mathematics to create tiles for artistic things. I think it would be a good pairing. I'll remember you. Any announcements? Is it time for schmoozing? It is. Thank you, Drew. Thank you, Dennis.